suppose you have a system that is very unbalanced, right? And a lot of current start to flow at the neutral. What would eventually happen?
So essentially, what would happen if you have current going back on the neutral? It will become a very inefficient system.
Transformer, all right?
Inefficient transformer. Overload after a while.
Yeah, and the neutral can burn out.
Yeah.
Right?
As you notice, many of us are familiar with the transformer blow. Out on the pole. That is exactly what happens when you have a poorly balanced three-phase system.
All right.
Our phase system.
When
that amount of current goes back on the neutral, if the neutral is not sized properly, or the central transformer is not sized properly, it will explode.
Alright, well, on that topic, right? So we study, we look at pad-mounted transformer, we look at internal transformer and so forth. There's another transformer out on the road now. We refer to them as.
So that is what they call a pole-mounted.
Pole-mounted transformer, alright. Follow the pole-mounted, right? Because everybody in Jamaica says the transformer on the pole. Yes, the pole, right? Recently, I went down by Agla Park Road, right? And I went to a commercial installation, right? And there were 2 transformers in a bank. A bank of 2 transformers there for a commercial facility. I want to find out, can I get a 3-phase supply from those 2 transformers? A bank of 2 transformers, 3-phase supply.
Yes, you can.
You can get a 3-phase supply?
I don't remember exactly how, but yes, you can.
You can get a 3-phase, alright? So in that case, with those 2 transformers, how many fuses would I need for those on the primary side?
On the primary side, you need 2.
You need two fuses, alright. So you say I can get a 3-phase from those 2 transformers, right? So in that case, then that will be an open delta. And with an open delta, I would actually get about 67% of the closed delta. A closed delta, right? So you can. All right. So a pole mounted. So with the Edison delta, now, if I have a transformer, a bank of 3 transformer, and I have an Edison delta system, which is a low voltage 4-wire with the I leg, 190 I leg, right? Oh, I get the I leg from that to get the neutral. No, I'll get the neutral from those 3 transformers. How would I get the neutral from that system?
So
the delta system that get a neutral.
The delta system.
Right.
Looking at a phasor diagram.
Yeah.
What you recognize is that a delta is
so
you have each end of the coils
close
connected to each other.
Close
delta.
From
your A phase to B phase. Should be these two lower ones. You center tap neutral.
So we center tap one of the phase transformer, right? And when we center tap it, what we do?
So from that now, you would get a neutral going out. It is literally just half of one coil.
Okay, right? So when we center tap it, what we're supposed to do in order for that neutral to become effective, because some of us want to center tap it and leave it there. No, we want it to be effective enough. Because it will float, and will float the trouble.
From that now, it become a grounded conductor.
Oh, it become a grounded conductor, right?
So you have to connect a grounding electrode.
So it So in other words, it has to be properly grounded for it to be effective. All right, so Mr. Dallas, I appreciate this, this it's a one-on-one, and I do a lot of engineers. You're going to do a lot of engineers from this. This is an open delta.
So where would you ground this? Where would you ground it?
You get the open delta now.
Open delta?
Yeah.
That's why he was talking about 2 lines coming in.
Yeah. So it's 2. Yeah. But you still want a neutral from that, right? You don't ground this though.
So one of these that still have to
be ground. Why next to happen?
Okay. Yeah, I see. These are. But those are your windings, the 2 transformers.
It's not one.
Or 2 windings,
If you 2 transformers, open delta.
Yeah. So open delta. So we can ground one of them still. Forget we do it. All right.
That's all I have to say.
Yeah. All right.